Hello everyone! Welcome to our channel, MeetABetterSelf. If you're new here, make sure to subscribe and hit that notification bell so you never miss our exciting videos on AI technology and personal development. Today we're continuing our exploration of the fascinating world of AI, delving deeper into its capabilities and the future of artificial intelligence. Are you ready? Let's get started. As AI technology advances, large language models, or LMs, have gained immense popularity for their ability to understand and generate human-like text. LMs have shown remarkable potential in various applications, including chatbots, translation, and even creative writing. ChatGPT, a powerful AI model, has demonstrated incredible abilities like answering complex questions, understanding context, and even generating human-like responses. Imagine having a personal AI assistant that can help you with anything from writing emails to planning your next vacation. Where did these thoughts come from? You may be surprised to learn that these abilities were not explicitly designed by researchers. They did not require language models to understand the size of every object or to know which content is fictional. Instead, the AI models learned these thinking abilities on their own. As LMs grow in size and complexity, they exhibit self-learning thinking abilities. This means that they can learn and adapt without direct human input, essentially teaching themselves to perform tasks and solve problems. The development of AI models like GPT-3, Llama, and Palm has shown that increasing model size and training can lead to remarkable capabilities. GPT-3, for example, has a staggering 175 billion parameters. Meta released a new language model called Llama with 65 billion parameters, while Google launched Palm in April 2022 with 540 billion parameters. Google even previously released a language model with 16 trillion parameters. According to OpenAI CEO Sam Altman, GPT-4 will not have many more parameters than GPT-3, but everyone expects that GPT-5 will have 100 times more parameters than GPT-3. These models have demonstrated the power of AI in language understanding, problem solving, and even creative tasks like writing poetry or composing music. The self-learning abilities of these models were not explicitly programmed by researchers. Instead, they emerged as the models grew larger and more complex, showcasing the incredible potential of AI. With these rapid advancements, we are inching closer to achieving artificial general intelligence, or AGI. AGI refers to a machine that possesses human-level intelligence, capable of understanding, learning, and adapting to any intellectual task that humans can do. It may sound like a sci-fi movie, but it's closer to reality than you think. As we continue to develop more sophisticated AI models, we can expect even more impressive capabilities to emerge. This will undoubtedly shape the way we interact with technology and the world around us, opening up new possibilities for innovation and collaboration between humans and AI. As storage costs decrease and hardware technology advances, it becomes more feasible to develop and train larger AI models. This progress is crucial for unlocking the full potential of AI, enabling the emergence of new abilities and smarter AI systems. Growing refers to a phenomenon where a qualitative change occurs due to a quantitative change. As AI models grow in size and complexity, they exhibit emergent abilities that were not explicitly programmed. This emergence is a fascinating aspect of AI development, as it showcases the potential for AI to discover new abilities and excel in various tasks. Neural networks, the building blocks of AI, learn through a process of trial and error, adjusting their parameters based on the feedback received. As the training process progresses, the model becomes better at recognizing patterns and making predictions. This process is essential for the development of AI's thinking abilities. As AI models grow in size and receive more training, their abilities improve, leading to a qualitative change in their performance. This means that they can tackle more complex tasks and exhibit new abilities, making them more versatile and human-like in their thinking. Let's take a journey back in time. In 1981, the storage cost of 1 GB was $100,000, which dropped to $9,000 in 1990 and is now only a few cents. If you consider what progress AI science has made compared to the past, computer hardware conditions are the most significant advancement. Today, we are doing big models. When your model is big enough, the corpus used for training is large enough, and the training time is long enough, some magical phenomena will occur. In 2021, several researchers at OpenAI made an accidental discovery during the training of neural networks. Picture a student learning to give an impromptu speech. Initially, they can't imitate well and struggle to make sentences. As training deepens, they can imitate existing speeches well with few mistakes. But if you give them an unpracticed topic, they still can't speak well. So you let them continue to practice. Continuing to practice may seem pointless because they can already imitate well, but struggle when improvising. However, you persist and let them practice. Suddenly, one day, you are surprised to find that they can give impromptu speeches. This is a qualitative change caused by a quantitative change. Researchers call this phenomenon grokking. Grokking, what exactly happened? Let's explore another example. ChatGPT has a crucial ability called few-shot learning, which means that you give it 1 or 2 examples, and it can learn your meaning and provide similar output. For instance, I asked ChatGPT to imitate the example I gave and come up with a few primary school math questions. My example question was, Johnny has 3 apples. His mother gave him 2 more apples. How many apples does he have now? ChatGPT immediately came up with 5 questions, all in this style, such as Michael has 5 pens. He gave away 3 pens. How many pens does he have left? Few-shot learning is a key ability. You can use this ability to get ChatGPT to help you with many tasks. So how did this ability come about? From more parameters and training. The more parameters there are, the stronger the few-shot learning ability. And few-shot learning is just one of the abilities. There are many other abilities that emerge as the model becomes big enough. This remarkable growth in AI capabilities is transforming the way we interact with technology and has the potential to revolutionize various aspects of our lives. Emergence is a phenomenon observed in complex systems, where new properties or abilities arise that were not present in the individual components. In the context of large language models, this emergence manifests as newfound abilities like reasoning, problem-solving, and creativity, taking AI to new heights. One of the essential mechanisms behind AI's thinking abilities is the chain of thought. This process enables AI models to connect different pieces of information and reason through a series of related thoughts, much like how humans think and make decisions. For instance, in August 2022, researchers from Google Brain published a paper discussing some of the emergent abilities of large language models, including few-shot learning, performing addition and subtraction, large-scale multitask language understanding, and learning to classify, among others. These abilities only appear when the model parameters exceed 100 billion. Researchers did not deliberately implant these abilities into the model. The models discovered them autonomously, much like children growing up and surpassing their parents' expectations. The transformer architecture plays a crucial role in the emergence of these abilities. It allows models to discover relationships between words regardless of the type of relationship or distance. When researchers invented transformers, they did not anticipate the plethora of new abilities that would emerge. The key mechanism for emerging new abilities, chain of thought, enables the models to internally narrate all aspects of a subject when prompted. For example, if you ask the model to describe summer, it will say, "Summer is a sunny season where people can go swimming at the beach and have picnics outdoors," and so on. How does chain of thought give language models thinking ability? Consider the example of a baseball bat question. As soon as the model hears about baseball bats, it narrates all aspects of baseball bats, including size. Since your question includes putting in ears, size is a property worth noting. The model compares the size properties of both the bat and the ears. finding that they are incompatible and judges that it cannot be put in. As long as the thinking process can be described in language, language models have this thinking ability. For example, show the model a picture, a still from the Pixar movie WALL-E, and ask which studio created the character in the picture. If there is no chain of thought, the model will give a wrong answer. However, if you first ask the model to describe the picture in detail, it says, in the picture, there's a robot holding a Rubik's Cube. This photo is from WALL-E. That movie was made by Pixar. At this point, you can simply ask it which studio created the character, and it gets it right. By setting up the AI model to think first before answering questions, it can automatically employ the chain of thought, enhancing its thinking abilities. This process allows AI models to reason, solve problems, and even be creative in their responses. Some researchers believe that programming training might contribute to the development of chain of thought in AI models. Programming training requires AI to track functions from beginning to end, connecting distant pieces of information, which may lead to the spontaneous generation of the chain of thought mechanism. As models continue to evolve and grow, we can expect even more emergent abilities, revolutionizing the ways in which we interact with and utilize AI systems. Moving beyond text-based AI, multimodal large language models can process images, sound, and video, opening up new possibilities in AI applications. LLMs first convert various inputs into language and then process them using language models. On February 27th, Microsoft released a paper describing Cosmos 1, a multimodal large language model. Unlike ChatGPT, which only processes text, multimodal models like Cosmos one can handle pictures, sound, and video. The principle behind IMLMs is to first convert all inputs into language and then process them using a language model. These models can handle tasks like pattern recognition in images, similar to solving IQ test questions. The example of the still from WALL-E mentioned earlier comes from this paper, demonstrating chain of thought in speaking from pictures. There's another example in the paper that showcases the impressive capabilities of MeetABetterSelf. When shown a picture that looks like both a duck and a rabbit and asked to identify the animal, the model first says it's a duck. If prompted to reconsider, it can recognize the rabbit in the image, explaining that it sees rabbit ears in the pattern. This thinking process closely resembles human reasoning. By incorporating multimodal inputs, models like Cosmos 1 are expanding the potential applications of AI and enhancing their thinking abilities. The integration of chain of thought with multimodal processing allows these models to reason and make decisions in a manner that is strikingly similar to humans, paving the way for even more advanced AI systems in the future. AI capabilities can be categorized into 3 realms. The first realm involves accumulating parameters and training, allowing AI systems to achieve specific tasks, such as AlphaGo learning to play Go. The second realm sees the emergence of unexpected abilities as AI models grow and develop. Examples of this include AlphaZero's unique Go strategies that deviate from traditional human approaches and the chain of thought phenomenon in large language models. The ultimate goal is the third realm, where AI reaches artificial general intelligence with self-awareness and a moral sense. This level of development would involve AI systems capable of understanding their own existence and the ethical implications of their actions. They would make decisions based on a set of moral principles, much like humans do. By progressing through these realms, AI systems can evolve from being tools that perform specific tasks to entities that can reason, learn, and even exhibit ethical behavior. This journey illustrates the vast potential of AI and its ability to transform the world in ways we have yet to fully comprehend. As we witness the incredible advancements in AI, it's essential to reconsider our assumptions about AI and human thinking. We might find that AI's thinking processes are more similar to our own than we initially thought, which could have profound implications for our understanding of intelligence. AI has already demonstrated impressive thinking abilities and creativity, from composing music to generating captivating stories. This raises the question, can AI truly be creative, or is it merely replicating patterns it has learned from vast amounts of data? And if AI can be creative, what does that mean for human creativity? The chain of thought mechanism in AI might reveal important parallels between human thinking and AI's thought processes. As we learn more about how AI thinks, we may discover new insights into the nature of our own thoughts and the intricate connections that give rise to intelligence. With AI's rapid advancements, it's crucial to reevaluate the essential differences between the human brain and AI systems. As we uncover more similarities in thinking processes, we might begin to see AI as an extension of human intelligence rather than a separate entity. In summary, due to grokking and emergence, AI now has thinking abilities, including reasoning, analogy, few-shot learning, and more. As AI continues to advance, we need to rethink our previous assumptions about AI's capabilities and explore the potential similarities between human and AI thinking processes. As we explore the fascinating world of AI together, we invite you to join us on this journey of discovery. Don't forget to subscribe to our channel, MeetABetterSelf, and hit the notification bell to stay updated on our latest videos. Together, let's continue to learn, grow, and meet a better version of ourselves. Before we wrap up today's video, let's ponder an engaging and thought-provoking question. If AI continues to advance at this rapid pace, how might our lives and societies change in the next decade? What new opportunities and challenges will we face as AI becomes more integrated into our everyday lives? Thank you so much for joining us today. We hope you enjoyed this deep dive into the world of AI and its capabilities. Remember, by embracing AI, we have the potential to unlock incredible opportunities and create a better future for all. So let's continue to explore, learn, and grow together. As we part ways for now, I'd like to leave you with one last thought-provoking question. What role do you envision for AI in your life, and how can it help you become the best version of yourself? Share your thoughts in the comments section below, and let's keep the conversation going. Until next time, take care, and remember, the future is in our hands. Let's make it a bright one. Goodbye.